is on the mathematics of finance. So previously, like in Algebra 2, we always did the A of t equals P times 1 plus R over N TNT formula. And we would say things like, Colton invested $5,000, and then he waited 23 years before he took it out of that account. And that's not really things that we do, right, in real life. That doesn't make any sense, right? He doesn't just invest $5,000 and he's like, oh, I'll just wait until that grows. Like, we don't do that. Okay, so what we really do for investments is, for instance, like for my retirement account, I invest, I don't even know what it is, like $200 a month or something, and the University High School matches it. So they also put in $200 a month. They match up to a certain amount. And so then that means that I get $400 a month put into my retirement savings. And that's constantly getting interest on it over the next however many years that I teach, right? Does that make sense? So we need to consider what happens when we keep putting money into our account every week, every month, whatever, okay? So there's actually two different equations that we're going to be using today. So really quickly, though, let's review the ones that we do know. So it says Meredith invests money into two accounts. One is continuously compounded, which we don't often see that, well, ever see that with financial math, at 2.6% annual interest rate. And the other is compounded monthly at a 2.7% annual interest rate. So it says if she invests $500 into both accounts, how much will she have in total after 1 year? Okay, so we're going to set this up. So we're going to talk about the continuously, and we're going to talk about monthly. So our continuous formula is the A of t equals PE to the RT. And we're saying that she put in $500, and the continuous rate was that 2.6. So we're going to do 0.026, and it's compounded monthly. So we're going to do, or not compounded monthly, what am I talking about? Times 1 year. So we're trying to figure out how much she has after 1 year. So we put that in. Okay, and we get that she makes $513.17. So she has that much total. So she made like $13.17 off of her investment, right? So if we compound monthly, then we're using that other formula. So we're saying our amount after 1 year, we start with $500. Our rate now is 0.027. So it's a little bit bigger for our rate, but we're not compounding as much. We're just compounding every single month instead of continuously every single like millisecond, right? And so we're going to have 12 times 1 up there. So I do 1 plus 0.027, and then I take that 0.027 divided by 12, and then I raise it to the 12, and then I multiply by 500. Are you guys finding this on your calculator? Was it pretty close? Yeah, 513.67, so just a little bit more. Yeah, so that's when you do, right? So it's good to shop around. It's good to find what investments are the best. All right, so that involves something that we talk about, which is called APY. So it says sometimes it's useful to compare two different options of investment. So above, we had two different accounts, and one of them yielded a bit more than the other. Not much, but a little bit more, right? So in order to compare several different options, we use something called annual percentage yield. Okay, have you guys ever seen APY before, like on billboards and stuff? Yeah, so you'll see it around if you look around. So annual percentage yield means it's basically like the percentage rate that would yield the same outcome if it was only compounded at the end of each year. So in one of those examples we did at the end of the month, right? And one of them we did, or not at the end of the month, well, we were compounding every single month, I guess I should say. And one of them we were compounding every millisecond continuously. But we wanted to know how much we gained at the end of the year. So if I wanted to find the percent that I gained, right, I could do that. Do you guys remember how to do that like in Algebra 1 when you guys talked about percent change? You took the amount of change divided by the original. So if I took that amount of change for this first one, those $13.17, and I divided by my original, it ended up being like a 2.634% change. So I took the 13.17 divided by original, and I got 2.634%. So that's a little bit different than what it said, right? It said something like a 2.6 annual interest rate. So I've told you before, like banks are a little misleading with that. It's not actually like a 2.6% annual interest rate, right? Does it make sense? Because you're compounded monthly, daily, whatever. And then this other one, if I take my percent change, this is a good like formula to know for the SAT too. It's the amount of the change and divided by the original. That's what I did for that last one. So our amount of change is $13.67 divided by 500. So I get 2.734. So that has a bigger APY, annual percentage yield. Does that make sense? Okay, so you don't have to do it this way to find the annual percentage yield. There's an easier way. So it says Mrs. Cox invests $5,000 into Chase Bank at 4.17% annual interest compounded monthly. What is the equivalent APY? So basically, if you just set it up so it's 1 year with an unknown rate equal to 1 year. So we're going to say, let me think about what I'm doing. So I'm going to set up my $5,000. And I'm going to say, well, what rate would I have if it was just compounded at the end of 1 year? This is like P times 1 plus R to the 1T. That's what we're using. That's going to be set equal to our $5,000 and then with all this stuff. So I'm going to do 1 plus my rate 0.0417 divided by 12 to the 12 times 1. Okay. So it's always going to be kind of set up similarly. So this left side will always kind of be the same. Original amount, 1 plus R to the 1. Because we're just finding, well, what would be the rate after 1 single year if I just compounded once. Okay, and we divide by 5,000. So it will always happen that these 5,000s go away. Doesn't matter what you invested. And we'd have 1 plus R equals 1 plus 0.0417 divided by 12, and then raised to the 12. So we just want to solve for R. We're trying to find the rate that we got at the end of 1 year. So we're going to take all of this. And we're going to raise it to the 12. Oh, did I mess something up? Oh, I divided by 12. That doesn't make any sense. 1 plus 0.0417 divided by 12 raised to 12. So I got 1 point. I knew I messed up because I was getting a negative. I was like, what did I do wrong? Okay, so I have that, and then I subtract my 1 over. So my rate then is 0.0425, which is a 4.25%. So I know it's a little weird what we just did. So we used our normal equation, and we said, well, what's the equivalent rate if I just compounded? So if this was like divide by 1, raise the 1. So if I just compounded 1 time at the end of a single year. So at the end of a single year, I would have had this much money, 4.25% increase. Does that make sense? Do you guys get what we did there? That's called the annual percentage yield. It's how much more we'd have percentage-wise at the end of a single year. These words make sense? Yield, percentage, annual. Okay, we're good. All right, so it says which investment is better, one that pays 3.75% compounded quarterly or one that pays 3.7% compounded monthly. So let's find the APY, the annual percentage yield for both of them. So if I do the 3.75% quarterly, it doesn't matter what I start with. I'm finding my rate after 1 year with whatever I started with over here with 0.03, and it's quarterly. So divided by 4 to the 4 times 1. So you can leave off the times 1 if you want. It's after 1 single year. Do you guys see how we set it up? Yeah, Greta?
So we're trying to find P.
We're trying to find R.
Okay.
So why do I not need to know P? Yeah, we're going to divide that out anyway, right? Does it make sense? So those P, whatever you invest, will go away. So we get 1 plus R equals, and we're going to find all that. So I'm going to do 1 plus 0.0375 divided by 4, and I'm going to raise it to the 4. I have more decimals here, but so it's around like a 3.803% yield. Okay. The reason I'm doing a few decimals there is because the other one's going to be really close to it. Like they're going to be very similar, so sometimes it's nice to have a few more decimals. All right, so how about the other one? So if I do an APY of 3.7% monthly, can you guys set up that equation? Let me solve it out. Did everybody get that equation right? Okay, good. I got like 3.763. Did you guys get somewhere around there? So that's the annual percentage yield. So which one's better then? Yeah, the one that's compounded quarterly. Does that make sense? Okay. So it says, suppose someone wants to deposit the same amount of money every month, every year, etc. So this is kind of what I was saying, like this is what I do with my investment for like a retirement account. I constantly put money in and it builds on itself. They say that the longer you guys have a retirement account, the better. So like you could put in, you know, $100 every single week, starting at 22 years old when you start working or whatever. And that would be much better than starting later and putting in like double the amount, right? So it builds, it keeps building every single year. So you're getting more and more and more. Okay, so it says, suppose someone wants to deposit the same amount of money every month, year, etc. This is called an annuity. Okay, so an annuity is like a sequence of equal periodic payments. That's going to be like a retirement account, investment account. So you're going to have a certain amount of money at the end of a certain amount of time. Usually with these annuities, you can't like take money out. Usually when you take money out, there's some kind of penalty. Okay, so for example, it says maybe Mrs. Cox is putting $200 into her 4% interest retirement account every month, and she wants to know how much she's going to have after she's worked for 40 years. Isn't that depressing when you see 40 years? Man, I got to work for 40 years before I can retire? That's crazy. All right, so the end of the first month is $200. Okay, the end of the second month, well, I have another $200 plus however much money that $200 has now grown to. Does that make sense? So the 200 times 1.04. Okay. And then the end of the third month, I have $200 plus, now I have that 408 times 1.04. Does that make sense? And then it says this process would take a long time to figure out how much you got after 40 years. You'd have to do every single month for 40 years. So how many months would that be? 12 times 40. You'd have to do this 480 times. So you can set up like an Excel spreadsheet and figure out what it would be that way. Okay, or we can use our calculator and use this formula. So we're going to use the formula. Okay, so the formula in your book, I will say, is very confusing. I have edited this formula to make it easier on you guys. So yay, thank you, Mrs. Cox. So here's the issue with the book. So our formula, future value. So future value, always think, okay, that's an investment. Future value of an annuity, it's going to be some kind of investment, retirement account, things like that. It starts out with R, which is your periodic payments. So that's how much you're putting in every month or every week or I think mine is actually bi-weekly. Bi-weekly means every 2 weeks, right? Because that's when I get a paycheck, so they take money out of that paycheck and put it in that. Does that make sense? And I is going to be an interest rate I per compounding period. So that's weird. So I is R divided by N. It's our normal interest rate divided by the number of, times you're compounding. So when you say per compounding period, it's like per month, per day, per week, whatever. And then N, capital N, is N times T. Okay, so remember how we had NT as our power before? We're going to have an N as well. So what the book does is it uses this N, and it just writes little n, which every single person then is like, oh, monthly, N is 12. And it drives me crazy because I'm like, why would they use the same thing? It's very weird. And I think they also use R, like little r instead of I. Okay, so we're writing it a little bit differently, so hopefully you won't be confused. Okay. So it says, at the end of each quarter, Manish puts $700 into his 403b. 403b is like a retirement account. It's the end of a quarter. Violet's like, wow, $700, Manish, that's good. You don't think he'd be responsible enough to put money into a retirement account? He what?
It comes from the YouTube channel.
Oh, does he have a YouTube channel?
Yeah, he has a YouTube channel.
Oh gosh, I did not know this. Am I more popular than Manish on YouTube? Which one?
He's more popular.
Really? You think?
I think she has.
I do have like 40-something thousand. I don't have very many subscribers.
Yeah, he has like 200 and something.
I have like 100.
He's on the come up, but he has like one video has like 1,000
He
views.
makes like what, $7 a year?
So we'll see.
Yeah.
All right. So if he has an aggressive investment plan and currently earns about this interest quarterly, how much will he be projected to have in his account after 25 years? Okay, so we got a lot of stuff going on in this formula. So let's write the formula. And I will give it to you, or I will give it to you on the test because you know what? I don't know it either. I have to flip back every single time. So I have R times 1 plus I to the n, what was it? Minus 1 over I. So it's kind of like a big parenthesis there. Like the R is going to be kind of at the very end. Make sense? So let's figure out what these things are. So R is our amount that we're putting in every quarter, month, or whatever, every compounding period. So it's our small amount that we're investing each time. And it says his interest rate is 9.2%. Well, that's little r from before, so 0.092. So my I is going to be little r divided by n. So it's going to be that 0.092 divided by quarterly, which is 4. So that's what I was saying was tricky for students. So we get 0.023. And then capital N is our number of times we're compounding each year times our number of years. So we're saying he's compounding quarterly for 25 years. So there's 100 times that it's going to get interest, right? And that he's investing money 100 times. So he's going to have at least $70,000. You guys see where I got the $70,000? Because he's putting in $700 100 times, right? Does it make sense? So he's making at least that. But there's interest that's being compounded over a long time, over 25 years. So we start plugging in. So we're like, okay, our future value is going to be 700. I'm going to have my 1 plus I, 0.023, to the n, which is 100, minus 1, all over I, which is 0.023. And we start putting this all in. And we get 265,500 and no, 321. $321.23. Did you guys get that number? You did it? Okay, let's do one thing at a time. So did you do your 1 plus 0.023? And then raise to the 100. So like hit enter after you do 1 plus 0.023. Raise the 100. Minus 1. Hit enter. Divide by 0.023. And then times the 700. So you could do this all on your calculator all at once, but you'd need a lot of parentheses. So I'm just kind of doing one piece at a time. Okay, do you think Manish has enough to retire? No, he doesn't have anything close to the amount that you need to retire. Do you guys know what the predicted amount a person needs for retirement? It's $1 million. You should have $1 million saved in your retirement account before you retire. Manish has 265,000, so his YouTube videos are not cutting it. And he needs to work for longer than 25 years. 25 years is not very long to work. If you're only going to work 25 years, you better be putting a lot of money in your retirement account, right? All right, so here we go. So it says Michael puts $150 into his retirement account every 2 weeks, and his employer matches his contribution. So that's a pretty sweet deal when your employer matches. So you got to look for that when you're looking for jobs. Also putting in $150. My life hacks thing, though, is you never ask things like that during a first interview. Do you know this? You're not going to be like, do you guys match for the retirement account, like assuming that you're going to get the job. Don't do that. Wait until they call you back and they offer you a job before you ask questions. All right, so he's putting in an every 2 weeks. So that's what I said was like the bi-weekly thing. So what's N in that case? Every 2 weeks. 2 divided by 52. Not 2 divided by 52. 52 divided by 2, right? Yeah, it'd be 26. A little confusing for students because they always say, oh, but there's four weeks in a month, right? A little bit more. So every 2 weeks, there's 52 weeks in a year, so that'd be 26 times a year. Okay, so his employer's matching and putting $150. So that means our R is now $150 plus another $150. So we're actually putting in $300 every 2 weeks. And our interest rate is going to be that 0.025 number, but it's biweekly, so we're going to divide by 26. So it's not a very nice number. It gave it to me in scientific notation, so you might store that number. So I'm going to store it as A. So I hit stow, alpha A. Y'all remember how to do that, right? And the last number we need is capital N. What's N? 26 times 25 years. Is it 25 years? Yeah. So we get 650 times. Okay, so we have our future value formula. So we have our R, we have our 1 plus I to the N minus 1 all over I. So R is 300. Our I is that number I stored as A, so I'll just kind of circle it so I know it's a stored number. Raised to the 650 minus 1 over that same number I stored. You with me? All right. Do you guys need calculators? KJ, do you need a calculator? Yeah, grab a calculator. I always have those calculators sitting on my desk. You guys can grab them. So start putting it all in. Make sure you get the same thing. Lots of sevens, geez. So does he have enough? No. It's 270,000, still not enough, right? All right, is that what you guys got? Yes, okay. Okay, so it says suppose you don't have an investment, but instead you need to make payments on something. Okay, so we just learned the formula, which was called the future value of an annuity. So annuities are investments. Future value is something way in the future that you're hoping to get. Okay, this other formula is called present value. You have to know the difference between the formulas. Can you guys know the difference between the formulas? All right, present value of an annuity. All right, so an annuity is still an investment, and things like a house. A house is an investment, right? Tell me why you guys think a house is an investment. Yeah, Kenzie? Yeah, hopefully your house increases in value, hopefully. But you're also putting money in every single month, and it's kind of, I mean, at worst case scenario, you should probably get the same return. Sometimes houses do go down in value, but hopefully you get kind of the same return. And hopefully you make improvements over the year. The house gets even better, right? And you can sell it for higher. So yeah, sometimes it's kind of an investment. Cars, I don't know if that's necessarily an investment, but we'll see. So it says, suppose you don't have an investment, but instead you need to make payments on something that you're purchasing now. So like a house or a car. Okay, this is not using the same formula. Instead, it uses something that we call the present value formula. And this is what the bank uses to determine what your payment should be. Okay, so when you buy a car, if the car says it's $25,000 and you get a loan from the bank, do you think that you pay the bank back $25,000? What do you think happens? Yeah, you have to pay interest, right? So you end up paying like $30,000 for your car. Does this make sense? Yeah. So let's figure this out. So it says, oh, Violet, it's you. Violet purchases a beautiful BMW for her 17th birthday. You've already turned 17, haven't you? Or no, maybe you haven't. Yeah, 16. She tells her parents that she will pay for the car by selling cupcakes for the next 10 years. She's a very good baker. I've eaten her baked goods. This is completely ridiculous. Never have a 10-year car loan. Why would you not want to take a car loan out for 10 years? Because, yeah, usually it lasts about 10 years, right? And then you're still paying for a car that you may not have. That's really awkward when you're still paying for a car that you don't have. Don't do that. Okay, the car costs $32,500. What are the monthly payments if she puts $2,500 down, so like as a down payment, and her annual interest rate is 3.1%? Okay, so we're going to go through this again. The numbers in this formula are very similar to what we did before. So R is going to be our payments. That's what we don't know. We're trying to figure that out. Our present value is how much the original loan was for. I is going to be that 3.1% divided by the number of payments she's making every year. So 12 payments a year, right?
Do you subtract 2,500 from 32?
Ah, good question. So the question was, do we subtract 2,500? I guess I didn't find that number up there, did I? The original loan amount? Yes, you do. So Greta has a good point. She said, you know, that car cost $32,500, but she paid $2,500 right away. So is she going to take out a loan for that $2,500? No, she's not, right? So we're going to take our $32,500 and we're going to subtract out that $2,500. So she's taking out a loan for $30,000. So this was our down payment. Do you guys all know what that means, down payment? Okay. And then our capital N is going to be the number of times per year, so 12 times the number of years. So how long is this loan going to be? 10 years, which I said don't ever do, right? All right, so we start solving this out. So we know our present value is $30,000. That's the present amount that she's taking out in a loan. R is what we're trying to solve for. We have 1 minus I, so 0.00258, and then 3 repeating. Now it's to the negative n, so negative 120, divided by I, which is 0.00258, 3 repeating. I would probably maybe store that number because I've rounded it, right? I have that 3 repeating thing. So I'm going to hit store as alpha A. So I've stored that as alpha A, stored as alpha A. Especially with these loan problems, because sometimes it does make a big difference if you round those numbers. Okay, so we got a lot of computing to do. Do you guys see the order that we're probably going to go in? Yeah, so I'm going to do the 1 minus my A first. I'm going to hit enter. I'm going to raise to the negative 120. I'm going to do 1 minus the answer. You guys know how to get answer. 1 minus answer, 1 minus.
Isn't it 1 plus I?
Oh, it was a plus, dang it. See, I told you I messed up this formula too. So this is a plus, thank you. So Greta gets a point. Okay, so do 1 plus A. So good thing I stored my number, right? 1 plus A. Raised to the negative 120. 1 minus that answer, divide by alpha A. So I have R times, and all of that reduces out to be 103.0683 something. Do you guys have that? You have a negative? Did you do answer minus 1 maybe?
Mhm.
Do 1 minus answer. So multiply by negative 1. Okay, are we to this point? You guys should all have your calculator out. Try this along with me. You don't want to start trying this formula for the first time on your homework. Like, try it now. Kenzie's like, I have mine. That's good. Okay, so we're going to divide by 103, that number. So I'm going to do 30,000, and then I'm going to do divide by answer. What do we get? Yeah, does that make sense for someone to pay around $300 a month for a car? Yeah, I think it makes sense, right? For 10 years, yeah, that's a lot. Maybe buy used. All right. Buy from John Walls. He sold me both my cars.
Where even is his dealership?
Greenfield.
Okay.
Yeah. I didn't go to his
Yeah, he's
dealership.
probably
Yeah.
for sure.
All right.
Yeah, Donovan?
Yeah. All right. So number 2. So Dr. and Mrs. Hogan purchased a new home for $250,000. They saved for. Oh, let's figure out. You know, I didn't do this. I didn't ask for this, but this is always a good thing to figure out. So if you're paying $291 a month, and she's paying for that for 10 years, 12 times a year. So how many payments is she making on that? For 10 years. 120. So take that number and multiply by 120. So the amount she really paid for this car was her $291.07 multiplied by 120 payments. So that gives me $34,928.29. But what else did she pay? Plus a down payment, right? Plus $2,500. So instead of that car costing her $32,500, it really cost $37,428.29. So a little bit of interest, right? All right, but not too terrible. That wasn't too bad. All right, so Dr. and Mrs. Hogan purchased a new home for $250,000. They saved for several years, and they made an initial down payment of $45,000. Okay, so that $250,000 minus the $45,000. How much are they taking out a loan for? $205,000, right? That's going to be their loan amount. That's going to be the present value. $205,000. Their rate is 0.0375, but remember in these formulas we divide by the number of months we're doing it every year. So I have 0.003125, which you can store if you want to. Sometimes it's nice to store that value. And then find n and set up your equation. Okay, so a lot of times with mortgages, you have a couple choices. You can pay, like the two types of mortgages usually are 15 years or 30 years. So they can't decide. They can't decide if they're going to do a 30-year mortgage or a 15-year mortgage, right? So let's start with the 30-year. So it's the number of years times 12, right? So the nice thing about a 30-year mortgage is that your payments per month is a little bit less, right? What can be the downside of a 30-year mortgage? You have to do what? Yeah, you end up paying like way more interest, right? Because you're paying over a longer amount of time, right? So let's figure out how much they're paying for these houses if they have 30 years versus 15 years. Okay, so we're starting with that $205,000 or $205,000. Wouldn't that be nice? $205. And we're going to have equals R. So R is what we're trying to find, times 1 minus, maybe I should not put the 15-year here. It's kind of long. 1 minus 1 plus R, and little r we found, or I it is, right? 0.003125 to the negative n. So n in this case is going to be 30 times 12, which is 360. So we're raising it to the negative 360, divided by I, so that 0.003125. Oh, that clickety-clack of all you guys putting this in. Oh, I just love it. What'd you guys get? Yeah, $949.38. Well, yeah, we'll say 39 cents. Okay, does that make sense for like paying for housing? Yeah, apartments. Apartments are like $500, $600 a month, right? So a house, probably more expensive. All right, let's compare 15-year. Same thing, but now our n is going to be 30 times 15. We're only going to make not 450. What am I talking about? Yeah, 450. Why is that more? What did I do wrong? Oh, not times 15. What am I saying? 15 times 12. I was like, why do I have this as bigger than my other payments? So 15 times 12, what is that? 180? Yeah, I guess makes sense. Half the payments, right? So we have 205,000 R. We're going to set it up the same. So 1 minus 1 plus. But now our, yeah, that's fine. So our number, our 0.003125 is the same. But now we're raising it to the negative 180. Do you guys have it? Okay, so I got my 205,000 and I end up dividing by 137.5. Do you guys have 137.5 something? What do you guys get now for the payments? $1,490.81. Do you guys all get that number? Perfect. To the decimal, did you guys figure it out perfectly? You're storing your numbers. I'm so proud. All right, so the question is, so that's going to be their monthly payments for each of them. So do you guys see the downfall of doing the 15-year? More money, right? But if you're making money, if you're like working and you have a really good job and you can make that payment, that's a good idea. Because it says how much would they have to pay for the house at the end of 15 years versus 30 years. So for 30 years, we would take that $949.39 and we would multiply by how many times am I making payments for 30 years? 360. And then I also added my down payment, which was $45,000, right? So they end up paying $386,780.40 for a $250,000 home. But for a 15-year, you take that 1490.81 and multiply by 15, and then add in the $45,000. Oh, geez, yeah, times 180. Thank you. Who got me on that, Brooke? Okay, so when I multiply it, I get 1490.81 times 180. So a little bit less, right? $313,345.80. So not a ton less, but I mean $75,000 or $73,000 less, right? I'll take that money. Definitely. Okay, does this make sense? Do you guys get it? Is that the last problem? Yep. All right. So